Hello dear students. In this video, let us take an exercise as follows. One recursive function has been given to us, and the question is, what is the recurrence relation for the above code? Just check if fun is called with the parameter n, then first thing it does is it runs this loop which runs I from 1 to n, but each time I is multiplied by 2. Now you very well know from the earlier video that this loop is going to run the operation log of n to the base 2 times. And then there are two recursive calls. After this work getting done, there are two recursive calls. So fun calls itself with n by 2, and again fun calls itself with n by 2. So we can write this as 2 times fun n by 2 added with log of n to the base 2. So this becomes the value of fun n. But this is possible only if n is 1, n is greater than 1. If n is greater than 1, only then this is applicable. Isn't it so? So what if n is equal to 1? Yes. If n is equal to 1, then this if will not run and only else will run, which has only one statement. So we can say fun n is exactly 1 if n is 1, because there is only one operation getting done. And now this recurrence relation can be solved using Master's theorem, isn't it? Because it is perfectly in the form of Master's theorem. Master's theorem says if you have a recurrence relation as Tn is equal to Atn by b plus n raised to k into log raised to p of n to the base 2. If you have a recurrence relation of this form, you can apply Master's theorem. Okay, but that's not our topic. We are not finding time complexity, but we are trying to find out the recurrence relation for the given function, and we have done that. Let's see one more exercise. Here we go. What is the recurrence relation for this function? You can pause the video and you can first of all find out the answer. Okay, here we go. Suppose we call fun with parameter n, then what does it do first? It runs a nested for loop, you see, and there is a for loop where I goes from 1 to n. So definitely, and I plus plus has been written. So this loop runs n times. But inside this loop, there is another loop, nested loop, which also runs from 1 to n. So there is a loop running n times, which repeats a loop which runs n times. So naturally, the total times this loops runs will be n square, isn't it? And this printf, the operation is performed n square times. So we can write here that the first thing it does, it runs the nested for loop, which runs n into n times. That means printf runs n square times. But after that, there is fun function recursion getting called with n by 2 parameter. So we can say fun n, if fun is called with parameter n, then it calls fun itself with the parameter n by 2 after doing this much work of n square. But this is applicable only if n is greater than 1. Observe, this entire thing has been written with if n is greater than 1. So what if n is not greater than 1? This if will not run, and this printf will run in the else, which is simply one operation. So we can say fun n is nothing but 1 if n is equal to 1. And now we can solve this. We can solve this recurrence relation using Master's theorem, isn't it? It is perfectly in the form of Master's theorem. Given the values of a is 1, correct? B is 2, k is 2. You observe this is n raised to k here. So k is 2 and p is 0 because log term is missing. And then you can find out which case do we fit in there, because there were 3 cases in the Master's theorem, and find out the answer. Anyway, now just check this. What will be the recurrence relation for the given code here? You can again pause the video and first of all find out the answer. What is going to be the recurrence relation for this? Just see, if fun is called with the parameter n, then this nested for loop will run. and the nested for loop is going to run n times followed by n times. So this printf is surely going to run n square times. And then after doing this much work of n square times, there are two recursive calls. Fun calls itself with parameter n by 2 and fun calls again itself with parameter n by 2. That means we can write fun when called with parameter n repeats the recursion two times with the parameter n by 2 added with that n square work done by the nested for loops. But this is possible only if n is greater than 1. But if n is 1, then fun n simply executes the printf written at the bottom. So fun n is 1 if n is equal to 1. This is the recurrence relation for the given recursive function, isn't it? Here we go, one more exercise. Again, you can pause the video and check what will be the recurrence relation for this particular function. Just check out that. What is it going to be? Let's see. If fun is called with parameter n, so we are talking about, oh, so sorry, wait a minute. So we are talking about fun n. What is the recurrence relation for this? Observe the first thing it does, it runs the for loop 1 to n times with I plus plus. So surely this loop will run n times. But then for every occurrence of this for loop, there is another for loop which also runs 1 to n with j plus plus. You see the increment is just plus plus. So this also runs n times. And then for every occurrence of this j, there is k which goes from 1 to n, but k is getting multiplied with 2, isn't it? Now we have a loop where k goes from 1, goes up to n, and k becomes k multiplied by 2, isn't it? Clearly this loop will run log of n to the base 2 times. I'm not going through the entire story again, isn't it? So we know that here the increment is multiplication by 2 and k will very quickly reach n within log of n to the base 2 times. So this runs log of n to the base 2 times, and there is a printf statement which runs within the nested for loops. Now there are three for loops nested one in the other. So how many times will this printf run? Printf will run n square into log of n to the base 2 times. I hope you have got that. Yes, indeed, you should. You should get this. It runs n into log of n to the base 2 times. The printf runs that many times. But what happens after that? After that, after the nested for loop, there is a recursive call fun, which is called with the parameter n by 2. So fun n is nothing but fun n by 2 plus n square log n to the base 2. Very interesting, isn't it? Very interesting. But this is applicable only if n is greater than 1. Observe, all this is written in the if statement. But what is fun n if n is 1? It executes simply a printf statement. So it is exactly equal to 1 if n is 1. Once you get this recurrence relation, it is so easy to solve this by Master's theorem. You note that according to Master's theorem, here a is 1, b is 2 here, k is 2 because this is n raised to k, n square, and p is 1 because this is log of n to the base 2 raised to 1, because log raised to p it was and p is 1. You can just substitute the values and find out in which case do we fall in as far as Master's theorem is concerned, and find out the time complexity, isn't it? So quite a lot of examples we saw, and we saw from where does these recurrence relation appear. First of all, they appear due to recursive function, and then once you get them, you can easily solve them using Master's theorem. Thank you very much.